So this is our first lesson this semester, second semester. So we're going to talk about today lines that intersect circles and tangent properties. Our objectives today are to that you can identify circles, center of circle, radii, diameters, tangent, secants, and chords. And at the end of the lesson, you're going to also be able to use the properties of tangents and chords to solve problems. So first of all, a circle is a set of all points in a plane that are equidistant from a given point called the center. That means that every point on this circle is the same distance from that center point right there. A circle with center C is called circle C, and that's the circle symbol, a circle with the dot in the middle of it, circle C. Okay, so these are your two blanks in your notes, equidistant and center. Next, we're going to talk about the interior of a circle. It's the set of points inside the circle, so that's everything that's red here. And then the exterior of a circle is the set of points outside the circle, so that's everything that's blue, and obviously that would be everything that's outside the circle, okay? And again, inside and outside are your two blanks that are in your notes. All right, then we have the radius of the circle. This is our radius right here. It's in green. It's a segment from the center to a point on the circle, okay? And in this case, we actually have two more radii from this center to that side of the circle and from this center to that side of the circle. So this actually has an image of three different radii in this drawing. A radius can also be described as a segment whose endpoints are the center and a point on the circle. So again, these are your blanks, the underlined words. Then two circles are congruent if they have the same radius. So if two circles have the same length of radius here, then they are going to be congruent circles. The diameter of a circle is the distance across the circle through the center. Okay, so it's from one side of the circle to the other, but it has to go through the center of the circle. Again, these are your two blanks, distance and center. And the diameter is twice the length of the radius. And why is that? Because you have two radii here. So obviously from the center to the side and from this center to the side, you have two radii, right? So that would be why the diameter is twice the radius. All right. Here again, we got some more blanks. So this is a chord. So a chord is this AB right here. That's what a chord is. And it is a segment whose endpoints lie on the circle. Okay, so a segment has endpoints, right? And by the way, this would be chord AB. Okay, I'm going to write it right here, AB. And a chord has endpoints, right? So this is why it looks like this. Now, a secant is a line that intersects a circle at 2 points. So notice here this blue line, and I know it's a line because it has arrows on both ends. AB is a chord because it has endpoints. This line, line L, is a secant. Okay, so this one, if we were to let me just give it some points here just so you guys can see. So let's just call this DE, okay? All right, so if we were to write this, it would be DE, and it would have a line symbol over top of it, okay? Then when we're talking about a tangent, it's a line in the same plane as the, okay. So this secant was a line. It had arrows on either end, right? This was a chord. It had endpoints. Now, when we talk about a tangent line, it's a line in the same plane as a circle that intersects it at exactly 1 point. So that is this point down here, and we're going to call it CF, okay? So it's also M. So up here, this line up here could also be called line M, or sorry, line L up there, right? Now, the tangent could be called line M, or again, we could call it CF, okay? Just another way. And remember, it has arrows over top of both ends of that because it's a line. The point of tangent C is the point where the tangent and the circle intersect. Point right here, point C, okay? All right, now, I want you, we're going to work this one together, and then I'm going to have you guys do one more by yourself. So, on this one, we're going to talk about naming the circle. So the circle is going to be circle L. okay? And how do I know that? Because this is the center point of the circle right there, okay? Now, this, if we look at radii here, we're actually going to see, I see 3 different radii, okay? So if we just talk about something that's just simply a radius, and nothing else, so I can see LJ is a radius. See LJ right here, again, segment. Then we have also LK is a radius, and we have LM is a radius, okay? Now remember, a radius goes from the center to the circle, okay? Then we have a diameter. Now, diameter is going to be made up of 2 segments that, or a segment that goes through the center of the circle, and its endpoints are on the circle. So that would be the segment KM. So that's this one, from K to M, and notice it goes through the center of the circle there, okay? Then KM is also a chord, okay? So KM is a chord. Diameter is always a chord, but there's another chord, and that would be JM, okay? Now, again, if we talk about the endpoints here, J and M, that would be a chord. However, if we talk about the secant, now secant goes through the circle and it's a line. So notice those arrows on either end right here. So if we say JM with a line symbol over top of it, now that's a secant, okay? Our tangent would be our line M. Notice this little M right here. That's referring to that line right there, okay? And the point of tangency is this point right here, this H, okay? So on this next one, I want you guys, I'm going to pause the video, and I want you guys to pause the video. I want you to go ahead and do the check it out, and I want you to draw the things that are indicated 1 through 7, okay? Right here. So I want you to do 1 through 7 in this drawing yourself, okay? So center Q is right here. We're going to put our Q right there. Then it says radius QR, so I'm going to go Q up here to R. That's going to be a radius right from the center to the side of the circle. Now then we're going to draw a diameter, okay? So I'm going to draw a diameter, and I'm just going to go straight from the center over here, from the center to over there, because now I'm going through the center, and this is going to be my ST. That's a diameter. So it's basically a straight line through the center of the circle, okay? And now we got a chord, UV. So I'm going to do chord UV over here. Chord UV, UV, and so it's got 2 endpoints on the circle. Then we have a secant that is WX, okay? So let's see, how can we do this? So a secant is a line that goes through the circle, right? So this would be WX. And then we have a tangent, YZ, okay? So a tangent intersects the circle at one point, and it says it's YZ, okay? So we're going to put 2 points on this. So one of them is going to be Y, and the other one's going to be Z, right there. Okay, and our point of tangency, it says, is Y, so that's why our Y is at that point where the line intersects the circle. Now remember, a secant and a tangent are lines, so that means they got to have arrows at both ends of them, okay? So now we're going to learn some properties. So this first one says, if a line is tangent to the circle, then it is perpendicular to the radius drawn to the point of tangency. So the line tangent to the circle is the line perpendicular to the radius. So what does that mean? That means I have a right angle here, which also means there's a right angle there, right? Okay, then the converse is true. If a line is perpendicular to a radius of a circle at a point in the circle, then the line is tangent to the circle, okay? So if we know that there's a right angle there, then the line has to be tangent, okay? And if it is tangent, then we know there's a right angle. And remember also, if there's a right angle on one side of here, there has to be a right angle on the other side, okay? So it says L is tangent to circle A at the top. L is perpendicular to line AB, or segment AB. And then M is perpendicular to CD. Line M is perpendicular to CD at point D. So M is tangent to circle C. All right, so now we're going to tell whether AB is tangent to circle C, and we're going to explain our reasoning here. So if it's tangent, then there should be a right angle here, right? Because this is our radius, and this would be our tangent, right? Okay, so if that's true, there should be a right angle there. So we should be able to use Pythagorean's theorem here, right? So this would be our hypotenuse over here, right? And then these two sides, so we're going to use our formula a squared plus b squared equals c squared, and which is c, our hypotenuse, right? So isn't this whole segment over here going to be our c? It is, and that's going to be 13, right? So, because we're going to add the 5 plus the 8, okay? So we're going to do ac squared plus ab squared, and that should be equal to cb squared, okay? All right, so we're going to do 5 squared plus 12 squared. And what we want to know is it equal to our 13 squared. So this is 25 plus 144 equals 169. So 25 plus 144 is 169. So 169 does equal 169. So yes, it is tangent. So it is tangent. So tell whether AB is tangent to C. The answer is yes, because angle A is a right angle. Okay. Check it out, example 2, and figure out where should that right angle be. Where is your tangent intersect your radius? That's the question, right? So pause the video, go ahead, do this one, come back to me when you're done. Okay, so here again, on this one, our right angle should be here, right? If it is a tangent, okay? So this again is going to be our hypotenuse, right? So that's going to be our C. So we're going to do our a squared plus b squared equals c squared again. So we're going to do 8 squared plus 16 squared, and what we want to know is, does that equal 20 squared, right? Okay, so this is going to be 64 plus 256 equals 400. 64 plus 256 is actually 320, and 320 does not equal 400. So AB is not tangent to circle C. Okay? Talk about is if two segments are tangent to a circle from the same external point. Obviously, this is our external point right here. So we have AB and AC. Then those segments are congruent. So that means AB is congruent to AC, right? So AB and AC are tangent to circle B, so AB is congruent to AC. So we're going to use this property here. It says HK and HG are tangent, so that means these two segments have to be the same length. That means we can say HK is equal to HG. So we're going to say 5A minus 32 is equal to 4 plus 2A. We're going to subtract 2A from both sides. So that's going to give us 3A over here, and then we're going to add the 32 to both sides to get rid of the 32. So that's going to give us 36. Then we're going to divide both sides by 3. So A is going to be equal to 12. Now it's asking us not to solve for A, but to solve for HG. Okay, so we're going to then put that 3 back in HG. So that's going to be 4 plus 2 times 12. So that's going to be 4 plus 24, which is 28. Now there's a quick check we can do to determine if indeed this is the correct answer. And that would mean that we would find HK, okay, because these should be the same length, right? So if we're going to do our check, we're going to do HK. So now we're going to plug that 12 into there. So that's going to be 5 times 12 minus 32. So that's going to be 60 minus 32, which means HK is also equal to 28, and that's a good check. If they're not the same length, then we got the wrong value for A, and so when we plugged it back in, we got the wrong value for HG. Okay, so this next one, it says check it out. So RS and RT are tangents. So go ahead and do this problem, pause the video, and then come back to me when you're done. Okay, on this one again, we know that RS is congruent to RT. So RS equals RT. So we're going to say X over 4 is equal to X minus 6.3. Now here's the big question. What is the opposite of division? Because that x over 4 means that x is being divided by 4, right? So how do we get rid of that? Don't we multiply both sides by 4? We do, okay? So we're going to multiply both sides by 4 here. So that's going to get rid of our 4 there, so it's going to leave us x there. And then we got 4x over here, and then we're going to do minus 4 times. Remember, we have to distribute this to both terms. Y'all remember this? So 4 times 6.3 is 25.2. Okay, now we're going to subtract that 4x from both sides. That's going to give us negative 3x is equal to negative 25.2. And then we're going to divide both sides by negative 3. Remember, we're always doing opposite operations here to get the values for when we're solving for x, okay? So when we divide negative 25.2 divided by negative 3, a negative divided by a negative is a positive, so this is going to be 8.4, okay? So that's our value for x. Again, didn't ask us for that. They asked us to solve for RT. So RT, we're going to plug now that 8.4 in there. So that's going to be 8.4 minus 6.3. And so RT is going to be equal to, what is that, 2.1? Indeed. Now, how do we check this? The way we check this, again, is to put it in for RS, right? So RS is going to be equal to 8.4 divided by 4. So RS is also equal to 2.1, and that's what it should be if we got the right value for x, okay? All right, last one here of this property. Go ahead, do this one, come back to me when you're done. So again, it says RS and RT are tangents. So if that's the case, then once again, we know that RS and RT are congruent, right? So we're going to say RS is equal to RT. So that's going to be n plus 3. Whoops. Don't know what happened there. Is equal to 2n minus 1. So here we're going to subtract n from both sides. So that's now gone. So we got n over here, and we're going to add 1 to both sides. So n is equal to 4. Okay. So once again, we need to plug that in to find RS. So RS is equal to 4 plus 3, which equals 7. And recall again, if we want to check it, then we need to plug it in the other one as well. So RT is equal to 2 times 4, which is 8, minus 1, which is also 7. So it did check out, okay? All right, so our last one here says if PA and PB are congruent, so let's go ahead and mark that in our drawing. PA and PB are congruent. And then it says that PA is perpendicular to AO and PB is perpendicular to BO, which we can see is true because there's right angles right there. So what are AO and BO? These right here. AO and BO right here. What are those? Aren't those radii? So I'm going to say radius. Okay. And then it says, what statement can be made about AO and BO? AO and BO, if they're radii of the same circle, can't we say that AO is equal to BO? We sure can. Okay. And then what do we call PA? PA and PB. These are tangents, aren't they? Okay, then it says if PA is equal to 12, so if PA is equal to 12, then don't we also know that PB is equal to 12? And then it says BO is 5. Well, if BO is 5, then we know that AO is 5, right? And then it says, what is PO? So it's asking us for this length right here. So once again, we have a right triangle. You guys see that there? So can't we go, and isn't this the side that's opposite the hypotenuse? So that's going to be our C, isn't it? So we're going to do AP squared plus AO squared. That's going to be equal to PO squared, right? So AP is 12. 12 squared plus 5 squared is equal to PO squared. Some of y'all noticed what this is already. We've seen one like this earlier in the lesson. It's 144 plus 25. And that's going to be equal to PO squared. So this is 169 equals PO squared. And how do we get rid of a square? We take the square root of both sides, right? So we're going to take square root here, take square root there, and take square root there. So PO is going to be equal to 13. Okay?